Hey everybody, this is Larry. This is day 11 of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, array of doubled pairs. I usually stop these live, so yeah, fast forward if you need to, watch on 2x, whatever you need to do. Day 497 streak, so I don't know. It's kind of weird, right? Because 500 doesn't really mean anything, but it is a cool big number, so we'll see how that goes. Okay, so given an array of integers all of even length return true, it's possible to reorder it such that this is true. What does this mean? I have to parse what this means first. But basically, okay, it just means that every adjacent array is going to be equal to each other. Okay, that's fine. Maybe? What does this mean? Let me take a look at what that means. -2, -4. Oh, wait. Maybe I missed this. This got cropped in a weird place. I thought that it means it's equal to each other, but it actually means it's double each other. Okay. Oh, excuse me. Apologies. Hope that didn't whatever. Okay. So the first thing I would say to do about this stuff is okay. And there definitely may be ways you can do it with linear time. I don't know, but the first thing I would say is that if you see things like if there's a way to order things, right? If there's a way to order things, then meaning that you can order them in any way you want. The first thing I would look for to do is to sort the array, because because you can, if you can reorder it anyway, then sorting the array will give you some structure that maybe you can hope to abuse or exploit or whatever. In this case, I think from then you can have two strategies, right? One is either look for the doubled array, and then the other is the other way around. Look for the doubled number in the array or the halved number in the array. Because of rounding type issues, it seems easier to look for the double, because it's just easier to do that math. Though I think it's probably the same. It's just slightly easier in terms of edge cases and so forth. And from that, we can just find the double, group them, and then do it again. Yeah, I think that should be good. The only nuance here now that I just noticed is that there can be negative numbers, and if there are negative numbers, that's fine. We just have to sort by the absolute value so that we parse them from largest to smallest, so that when you look for double, it's going to be in the double. Yeah, I think that, and then you just put everything in the hash table, and that should be good. Let's get started. Hopefully that makes sense as a start. But let's see. We have yeah. Let's just do a count. Let's do a counter of things, and then we sort. And you can do this in okay. I usually maybe do something like this, but I think right now it probably, because maybe that's okay. Because this technically changes the input, so that's why I'm okay. Fine. Let's just do sorted. Let's make a copy of it. Key is equal to lambda of absolute of x. Oops, lambda of x. So basically, what this does is it sorts by the absolute value, but with the smaller number first. So we actually want to reverse this. You can either convert it to negative or just reverse equals true. The reverse or reversed. No, I think it's reversed. Reversed is the name. And then yeah, and then just for number in this thing. Oop, did I miss? Oh, why did it not? I'm just a little bit curious because it didn't. Oops. It should auto whatever. Let's run this real quick just in case I have a typo somewhere. No, okay, that's weird. Because the UI should. So what I noticed is that the UI should usually go to the tab, auto tab for you, but it didn't do it in that case for some reason. Okay. Anyway, it's not a big deal. So yeah, so okay. First of all, in a greedy kind of way, and this is greedy. You check to see if x is in count of x. So if count of x times 2 is greater than 0, then we make a pair, right? Then we just can do. And this actually handles negative number as well. Otherwise, if we cannot find it, then we increment it. And the reason why we increment it is so that we can... So we're trying to basically find a pairing in a greedy way, right? So if you can match it with a double, then you should match it with a double, because as you sort numbers from larger to smaller, in the future there's no way to match it, right? Like if x times 2 exists and you either match it now or you know, you'll never match it. So that's basically the idea. And in this case, and if you don't match it, that means that, you know, you have to get it by the other side, which is the smaller number will match it with the number later. So that's basically the idea here. And then you can do it in a couple of ways, but I'm just going to write it this way, where sum of counter. I think maybe there's even a value for this. Like I think counter has a helper method that does this, but anyway. So if every number gets matched, then we should be okay. And the idea here is that, and they don't ask you for the array, but in theory you can imagine that, okay, you have an array, and if this gets matched, then you just do that append of x, and then append of x times 2. Then now the two numbers will be matched next to each other, but that's not even necessary because that's not the problem. But yeah, okay. So that should be good enough for me to go on. It's nice of them to have an example with negative numbers so that they don't, you know, it would have been like 5 seconds to fix, but it would still be a wrong answer if I didn't read it correctly, which, to be frank, happens a lot. Okay, so this looks good. Array can be linked with 0. I guess it's true with 0, but let's, you know, let's just do some small cases. I think I'm pretty confident about this one though, but sometimes your confidence can be wrong, so that's why you test. And anyway, let's give it a submit. Cool. And this is going to be n log n because of the sorting. Yeah, I think you do need to sort though, because this greedy allows this property to be true. Because I'm thinking whether you can do it without it, but you can imagine something like 2 and 4, and like if you don't sort it in some way and try to do it in linear time, and maybe there's another way of doing linear time, but if you have something like this, for example, is that one of the inputs? Maybe that's one of the inputs. But when you have something like this, you greedily match these things without sorting, but then now you left these two out. But where you sort, you match the 1 with the 2 and the 4 and the 8, right? So this is going to be n log n time because of the sort, and O of n space because of the counter stuff. Yeah, and that's all I have, I think. Let me know what you think. Let me see if there's actually, let me, before I'm curious whether there's a linear time solution. Because, yeah, I mean, n log n is going to be fast enough for any competitor, but yeah, let's see. Okay, so their answer is n log n, and this is essentially the same thing, but this is much cleaner though. Yeah. I don't know what, I mean, don't know what this means, but I'm sure the logic is roughly the same, but they have some weird type thing for some reason, but maybe not weird, just a different explanation of what the count does. But I do, they put everything in the array first and then do a do a negative of it or something like that. So where I put nothing in the beginning and then I put it in one at a time. So we do have a different definition for count. That's why. But yeah, anyway, that's all I have for this one. Have a great Wednesday. Stay good, stay healthy, to good mental health. I'll see you later. Bye bye.